Okay. So confidence interval. Let us recall what is confidence interval. Recall. Okay. So suppose x1, x2, etc. xn be n random samples from a population. So there is a large population and we are taken n random samples from a population with the mean mu and standard deviation sigma. Okay, so that means each random variable x1, x2 are random sample has mean mu and sigma, standard deviation sigma. Then we know that by central limit theorem, x bar follows normal mu by sigma by root. That means random sample, mean of the random samples follows normal distribution with the mean mu and standard. So this we can convert into standard normal distribution. X bar minus mu by sigma by root n follows normal 0, 1. Now if mean mu is unknown, we don't know what is mean mu. That means mean of the population is unknown, we don't know. Then we can estimate mean in an interval, okay, by using sample mean. So mean of the population we can estimate by using sample mean with a confidence of 95% or 90% or 99% confidence interval. So this mean can be tested by using a test statistic, that is sample mean. Test statistic is sample mean x bar. Okay. Now let us recall this. Suppose this is our normal standard normal curve. Then suppose this is z alpha by 2 minus z alpha by 2, and this is z alpha by 2. Then this area, that is P of mod z less than z alpha by 2 is equal to 1 minus alpha. That means this area is 1 minus alpha percentage. Okay, and this alpha by 2. So if we want to calculate P of mod z less than z alpha by 2 is equal to 95% or 0.95, that is 1 minus 0.05, that is alpha is equal to 0.05. Then we know that this value from the table, z alpha by 2 is equal to 1.96. Okay, that means 95% confidence interval. Then from the table we can calculate that, we can find that z alpha by 2 is equal to 1.96, and 99% of confidence interval we will get z, that means mod z less than z alpha by 2 is 0.99, then z alpha by 2, or 0.99 means 0.1 by 2, 0.01 by 2 is equal to 2.58. Okay, similarly we can find 90%, z 0.1 by 2 is equal to, from the table, 1.65 or something. Okay, so So then we have last class we discussed the confidence interval. For population mean. So first case is if mean mu is unknown, then the confidence interval is with the 95 percentage 95 percentage confidence interval is x bar, that is given minus 95 percentage means 1.96 sigma by root n, and x bar plus 1.96 sigma by root n. So this is the confidence interval for mean. That means mean, unknown mean. That means mean of the population may in the interval with 95 percentage of chance. That means mu belongs to this interval with a 95 percentage of chance. If we want to calculate at 99 percentage, this value is 2.58, or in general, if we want to calculate 1 minus alpha, 100 into 1 minus alpha percentage of confidence interval, then here it is that z alpha by 2. Okay, so we will do one more problem. The mean blood pressure of 100 randomly selected person from a target population is 127.3 units. That means the mean blood pressure of 100 randomly selected 100 samples, then the mean is find a 95 percentage confidence interval for the mean blood pressure of the population has standard deviation 25. Okay, so solution. So we have given n equal to number of samples, n equal to 100, and has selected as a population. That means mean of 100 samples is 127.3 units. That means x bar sample mean is 127.3. And also we have to find the 95 percentage confidence interval. So, and also given standard deviation of the population, sigma is 25. Now the 95 percentage confidence interval is, we know that interval x bar minus 95 percentage means z alpha by 2 is 1.96 sigma by root n, and x bar, that means mu belongs to this bar plus 1.96 sigma by root n. Therefore x bar is we have 27.3 minus 196 sigma is 25 by root n. N is 100, so root 100, and 127.3 minus 1.96 sigma into root 100. Okay, so if we calculate this, we will get okay, so I will share that. notes there calculated. Mm, okay. So, so if we calculate this, we will get this, right? We'll get the value 122.4, 132.2, 122.4, 132.2. So this is the confidence interval. That means mean mu belongs to this interval with a confidence of 95%. That means 95% chance that population mean will be in this interval. So similarly, you find this. A random sample of 110 a random sample of 110 lightning flashes. Sample of 110 lightning flashes in a certain region resulted in a sample average radar echo duration of 0.81 seconds and a sample standard deviation of 0.34 seconds. Calculate 99% of confidence interval for the average echo duration. Tell me what is n here. Tell me what is n, x bar, and is sigma is given. Tell me what is n here. N is number of samples. So here given it is random sample of 110. So n is 110. In a resulted in a sample average. Sample average means sample mean is given 0.81. And also here it is not given sample standard deviation, but sorry, population standard deviation, but here it is given S, sample standard deviation. Since n is very large, because 110 is very large, then instead of population sigma, instead of sigma, we can use S, sample standard deviation. Okay, since n is very large, so instead of S, we can use sigma. Okay. And we want 99% confidence interval. That means Z 99% confidence interval means Z 0.01 by 2. Z alpha by 2 is equal to 99%, 2.58, right? So the 99% confidence interval is very easy. This interval x bar minus 2.58 s by root n, because here sample standard deviation x bar plus 2.58 s by root n. So everything is given here. X bar is 0.81 minus 2.58 s 0 point into 0.34 divided by root 110, and x bar 0.81 plus 2.58, 0.34 divided by root 11. Now, if you calculate this, you will get an interval. So, I will already calculated in this notes. So, I will share these notes also. So, this is the value, and it is 0. This is that interval. So, the answer is this interval is 0.726, 0.726, 0.894. So the sample mean is 0.81, and the population mean has a 99% probability that it will belongs to this interval. Okay, so this is very easy finding confidence interval. Now next, confidence interval for a population proportion. Okay, this is same as what we done for a sample population done before. So okay, so let P be proportion of success in a population. P denote proportion of success in a population. Okay, so we have to estimate what is P. So for that, a random sample of n individuals is taken, is to be selected. So in a population, we have to calculate the proportion of success. So I am taking a random sample of n individuals, where x denote number of success. So we know that success in the sample. So x denote number of success in the sample. Now we know that number of success, and the other outcome is a failure. So x follows binomial n number of success and p probability of success. Then we know that expectation of this random sample is np, and variance is, we know that npq, where q is equal to 1 minus p. So x is number of success in the sample, therefore x follows binomial with the mean np and variance npq, and we know the standard deviation is therefore root np. Now proportion p is proportion of success, that means number of probability of success in the population, and the natural estimator for p is, what will be natural estimator of proportion p? Sample mean, right? Sample of success, that is, we denote p cap is equal to number of success divided by number of trials, that is sample. When this n is very large, we know that expectation of this p bar, this is equal to expectation of x divided by n. which is 1 by n. Expectation of x. Expectation of x is np, right? So np by n, which is p. So expectation of p bar is p, and variance v of p bar is equal to variance of x by n, which is 1 by n square variance of n, npq, which is equal to pq by n. Therefore, standard deviation of this is root pq by. So now this proportion p bar follows normal distribution when n is very large. N is large, that means np greater than 10. Then p cap follows normal distribution with the mean here p and standard deviation root pq by n, root of pq by n. Now, therefore z cap p bar minus p divided by root pq by n follows normal 0. Now we can find the confidence interval. That means if we don't know, so we got z is equal to p cap minus p divided by root pq by n follows normal 0 1. And if this p is unknown, now we can make a confidence interval. So if p of we know that p of mod z less than z alpha by 2 is equal to 1 minus alpha, then the confidence, then in general 100 into 1 minus alpha confidence interval is p of, okay, confidence interval is we will calculate p bar minus z alpha by 2 into standard deviation root pq by n, and p bar plus z alpha by 2 root pq by. So this is 100 into 1 minus alpha by alpha confidence interval. Now if we want to calculate 95% confidence interval, then this is p bar minus 95%, then 1.96 root pq by n, p plus 1.96 root pq by root n. Then similarly 99%, 90% we can calculate. So let us stop.